My name is Pierre Séguin, CAD instructor and support staff for the Engineering Graphics course at the Royal Military College of Canada. I should remind people that SOLIDWORKS is used for all the methods. The explanation in the presentation might work on other platforms as long as the software allows configurations and has a Deform tool that works in a similar way. This time, a part will be built directly in the file containing the master structure. The file prepared in the previous setup presentation is opened, and it should be saved again under a different name. In the normal configuration, a block similar in size to the other example is extruded. This means it is 110 mm wide by 100 high and 120 deep. Since it was created in the normal configuration, it will automatically appear in the other one. Remember that we turned off the suppress feature option for the oblique. This also means that we want to add the next feature in the oblique configuration because that way the normal configuration won't be affected as it is set to suppress. The deform feature is found in Insert Feature Deform, then the normal direction sketch line is inserted in the first box and the receding direction in the second. It is very important to activate the uniform option, and finally, after selecting the body, a preview will be displayed. After the feature is completed, we can see something wrong. The deformation was applied only in the region covered by the depth of the initial sketch line, leaving the farthest end of the block undeformed. This is a critical rule. The sketch line can be longer or equal, but not shorter. So the solution is again to make an equation. As soon as it's done, the block is now uniformly deformed. Switching to the front view, we can see that we have an oblique projection, and changing the configuration to normal show that it is unaffected by the deformation since the feature is suppressed. From that point, all the other features can be added in a conventional fashion as long as they are inserted before the deform feature. This can be easily achieved by a rollback before starting the addition, as could be seen in this picture. To have a nicer screen, it is not necessary to continue to see the master sketches system, and it could be hidden as well as the plane. I will go rapidly over the other sketches and features, including several points to construct a reference plane to cut an oblique surface. On the top face, a slanted sketch is also cut down. When switching to the oblique configuration, the part seems unchanged except for the sketches that reappeared. The reason is that the rollback affects all configurations. To keep the screen uncluttered, the sketches are hidden again. The part being now unrolled back, we can see the deformation, which is the oblique we were looking for, as well as the corresponding normal front view. The part can then be placed on the drawing sheet to show the orthographic, isometric, and oblique views. Some dimensions are added to show that the ratio is correctly maintained. Modifying the oblique to obtain a different angle is very easy. Simply changing the value is enough to reshape the part and update the drawing sheet. So, by changing a single value, it is possible to go through a whole range of angles. Let's say a drafting instructor would prefer to have the part fits in a grid similar to what we had in the original system. We will save it under a different name, then the angle and ratio sketch will be selected to be edited. The length will be deleted and replaced with a dimension on the horizontal line. The equation will reset itself. When the part is updated, the proportions will be different. The drawing confirms that the receding dimensions along the line are changed, but when replaced by horizontal dimensions, they now correspond to what would be expected in the grid system.